Hello students, I am Ekta. Today we are going to learn about the surface area of combination of solids. In class 9, we became familiar with solids like cubes, cuboids, cylinders, cones and spheres, and we know how to find their surface area and volumes. Today, in this session, we are going to learn about the combination of surface areas of different types of solids which are mentioned above. In our day-to-day life, we come across numerous objects and structures that are made up of combinations of basic geometric solids. For instance, when you look at a rocket, you will notice that is not just a single shape, but a combination of cylinders, cones, and spheres. The same goes for structures like water tankers, playground equipment, and even some architectural designs. In this session, we are going to dive into the exciting world of combining the surface areas of different types of solids. We will explore how to calculate the total surface area when these shapes come together to form more complex structures. Learning outcomes. After the completion of this lesson, you will be able to break down complex shapes into simpler components to calculate their total surface areas. Recognize situations where combination of shapes are used to create more complex structures. Identify real-life situations where the concept of surface area and combination are applied, such as packaging design, architecture, and engineering. Keywords: composite figure, total surface area, lateral surface area, joining, scooping, cutting. Students, let us solve a problem. Example: Umesh bought a playing top, Lattu, which had no color on it. He wanted to color it with crayons. The top is shaped like a cone surmounted by a hemisphere. The entire top is 5 cm in height and the diameter of the top is 3.5 cm. Find the surface area he has to color. Solution: given height of the top is equal to 5 cm. Diameter of the top is equal to 3.5 cm. Radius of the top is equal to diameter by 2 is equal to 3.5 by 2. Umesh wants to color the playing top. The top shape is like a cone surmounted by a hemisphere. So, we should add the curved surface area of the cone and the hemisphere to find the area that he has to color. We know that the curved surface area of the hemisphere is equal to 2 pi r square. Now, substitute the values in the formula. Is equal to 2 into 22 by 7 into 3.5 by 2 into 3.5 by 2. By cancelling the terms, we get is equal to 11 into 0.5 into 3.5. Is equal to 5.5 into 3.5. By multiplying, we get is equal to 19.25 centimeter square. Now, calculate the curved surface area of the cone. The curved surface area of the cone is equal to pi RL. Height of the cone is equal to 5 minus 3.5 by 2 centimeter is equal to 3.25 centimeter. We know the height of the top but not the slant height of the top. So, first find the slant height of the cone. To find the slant height of the cone, we are having the relation that is L square is equal to h square plus r square. L square is equal to 3.25 square plus 3.5 by 2 square. Squaring the terms, we get L square is equal to 10.5625 plus 12.25 by 4. By taking LCM, L square is equal to 10.56 into 4 plus 12.25 by 4. L square is equal to 42.24 plus 12.25 by 4. L square is equal to 54.59 by 4. By simplifying, we get L is equal to root 13.69. L is equal to 3.7 centimeter. Now, substitute the values in the curved surface area of cone. Formula is equal to pi RL is equal to 22 by 7 into 3.5 by 2 into 3.7. By cancelling the term, we get is equal to 11 into 0.5 into 3.7. Multiply the terms, we get is equal to 20.35 centimeter square. Therefore, the area of the top needed to color is equal to curved surface area of hemisphere plus curved surface area of cone is equal to 19.25. 20.35 is equal to 39.6 centimeter square. Students, let us solve one more problem. A wooden article was made by scooping outer hemisphere from each end of cylinder as shown in figure. If the height of the cylinder is 10 centimeter and the radius of its base is of 3.5 centimeter, find the total surface area of the article. Solution. In this question, we will calculate the curved surface area of cylinder and curved surface area of two hemisphere. Then we will get the total surface area of the article. Given height of the cylinder is equal to 10 centimeter. Radius of the cylinder is equal to 3.5 centimeter. We know the curved surface area of the cylinder is equal to 2 pi RH. Now, substitute the values in the formula. Is equal to 2 into 22 by 7 into 3.5 into 10. By cancelling the terms, we get is equal to 2 into 22 into 0.5 into 10 is equal to 44 into 5. After multiply all the above terms, we get is equal to 220 centimeters square. The curved surface area of the cylinder is equal to 220 centimeters square. Then we should calculate the curved surface areas of two hemispheres. The curved surface area of hemisphere is equal to 2 pi r square. So, curved surface area of two hemisphere is equal to 2 into 2 pi r square is equal to 4 pi r square. Now, substitute the values, we get is equal to 4 into 22 by 7 into 3.5 square. Is equal to 4 into 22 by 7 into 3.5 into 3.5. By cancellation, we get is equal to 4 into 22 into 0.5 into 3.5 is equal to 88 into 1.75. Multiply all the terms, we get is equal to 154 centimeters square. The curved surface area of two hemispheres is equal to 154 centimeters square. Therefore, the total surface area of the article is equal to curved surface area of cylinder plus curved surface area of two hemispheres is equal to 220 plus 154 is equal to 374 centimeters square. Students, now let us summarize what we have learned. A composite figure is a shape made up of multiple simpler shapes combined together. The total surface area of a solid is the sum of the areas of all its surface. Joining, scooping, cutting refers to the operations used to create composite figures by combining or modifying simpler shapes. Concept of surface area and combination are used in various fields like packaging, design, architecture and engineering to optimize materials and structures. Thanks for watching this video.